Okay, so first off, before I even introduce myself, I just kind of want to see what people think of this. How many of you have heard, if you're here, you've probably at least heard or played with Kubernetes, probably more than that, but how many of you have heard that Kubernetes will make your devs' lives easier in some way, shape, or fashion? Okay, yep, that's what I thought. Okay, now that's all fake. I'm just going to say it. That's hence the title. Kubernetes is not for developers and other things the hype never told you. So just a little bit of background. Now, I was going to give this talk with my coworker and friend Jordan. He couldn't make it to this conference. But we put this talk together since both of us have worked on Kubernetes platforms at various companies. I worked on it at Intel. We're actually both together at Nike. And now I'm currently at Microsoft working on AKS. So I've worked on various enterprise app platforms across different companies with different business needs. You have big companies like Intel where it's about supporting their main chip design efforts and other stuff. You have places like Nike where it's retail and supporting the business, and then there's Microsoft where it's actually building a Kubernetes platform for other people to use. So this talk is about some of what we learned along the way and cutting through some of these misconceptions that we see as we try to implement Kubernetes in our different environments. So first off, just a little introduction. This is our app dev. Our app dev generally will have at least one of these characteristics. Don't feel insulted if one of these does not describe you. These are just common stereotypes, often which have some truth to them. Generally, they like to write in, I like to call it ye old language. It's not really, but Java, C#, C++, kind of the main enterprise standards. Or another joke is they write perfect memory leak-free C++. In general, they're good, responsible developers. They know their craft well. Oftentimes, these people have been at the same company for a while. And because of that, they have a deep understanding of the org's business and how everything operates. And sometimes, depending on the developer, they're not as interested in some of the new flashy new things, but more about writing the good code or interesting technical problems to solve that way. They write the business logic of the apps that they're doing for whatever needs their businesses have. But they want to write good code that makes the company successful. I mean, we all eventually work at a company, and so we're paid to make our company successful. And so generally, they're pretty good at doing that. So this right here is what happens when app devs try to run services on Kubernetes. I mean, I don't even know what's going on, but you have tentacles of who knows what right there, and there's a fish on there. I don't even know how the fish got there. Did the wind blow it? The sail is flying away. Who knows what's going to happen to the poor little skinny tie? But I mean, if you just think about it, there are just so many knobs, dials, and switches on Kubernetes. You have this question, do I need a horizontal pod autoscaler? Load balancer service or an ingress? Which ingress controller do I use? How do I get the logs from all the instances of my app? Why are my pods getting evicted? Is that going to take down my app? What's the difference between a resource limit and a resource request? And how is that going to affect my app? What if I need something like a GPU? What do I do to get that? Hey, that network policy thing, is that another firewall? What's a pod security policy? Should I be setting that up? It sounds important. How do I do something to warm up caches or create data directories ahead of time? What storage class should I use? I could keep going and going and going and going about all the different knobs and switches. And honestly, Kubernetes is hard. That is too much than most of these developers want to touch. But beyond that, if this is so difficult, why bother with doing it? Well, besides Kubernetes being a shiny new platform, and I can't tell you how many times somebody comes and says, hey, we need Kubernetes. We're like, great. What are you running on it? Oh, we're running such and such app. OK, so why do you need Kubernetes? Because Kubernetes. And so I'm like, OK, that's great. We have this idea of OK, you're telling me to build a foundation for a house. Are we building this on the beach? Are we building this in the mountains? Are we building this in the suburbs? Those are entirely different ways you build the foundation. And people are just kind of like, yay, Kubernetes, because they've been told, oh, this will make developers' lives so much easier. But even though those things that I said before, yes, they are difficult, all those knobs and switches are actually really useful abstractions. Just our poor developer that I explained earlier doesn't want to have to deal with those abstractions. These are actually amazing building blocks that you can use to build powerful application platforms. Kubernetes at its heart is a set of primitives that accurately represent your actual infrastructure that's going on underneath. And really there's some measurable benefit that I've seen from using Kubernetes. And for some businesses, it is a competitive advantage, but for sure if you have everything set up and everything configured correctly, you'll be able to deploy quickly and safely. And you get automatic self-healing, rolling updates, scalability, extensibility, et cetera, that comes with Kubernetes. So if you're going to bother with it, which is generally a good thing, you're going to want to bring in an expert. So introducing our platform dev. I'm assuming if you're here at this conference and at this session, you're probably leaning more towards the platform dev side. If you're an app dev, welcome app devs. But in this case, our platform dev, she's a cloud infra expert. So generally, they're tasked with building out the platform to run the business's many apps that are going on. So whatever those needs are, they're kind of the main point person to take care of that. Now, like the app dev, I'm going to go through some of the stereotypical characteristics. Some of them may apply to you, some may not. Generally, a platform dev knows tools like Kubernetes, console, container runtimes, those types of tools that are out there. Many platform devs, including myself, that I've talked to, have some sort of ops background. Not that they did it for a long time or that they're like a classic Linux graybeard, but they have some sort of ops background, and those experiences have kind of led them to do things like Kubernetes because it's way better than other things that they've done. Often they're less focused on the business logic part of these applications and more focused on the distributed system side of things. So fault tolerance, recovery, scheduling, all those things around a distributed system. As it's been said multiple times in the conference already, and we hear all the time, distributed systems are kind of a beast. They bring their own set of problems. So this is where we get to the mind the gap, which is fitting because I keep hearing that on the tube everywhere. So the thing is, as a platform dev, it's up to you to decide how you want to use the abstractions that Kubernetes provides for you. And that quote I have underneath right there is kind of how we sum this all up, that responsible Kubernetes users limit their own options by abstracting away what is constant within their organization. So if you're a platform dev, this is going to be your job. So let's, how do we do that? So what we have to do is talk to the application developers. And you have to find out what's important to them. Now, some of these might sound like platitudes. I'm going to dive in a little bit more into some of these in a second, but you have to listen to what hurts. And then build a platform that works the way they think. And just be prepared that it will evolve over time. Pick something very targeted to start with and then evolve it, because otherwise you're going to end up boiling the ocean. So then, practical stuff. What are the actual things you should listen for? The last stuff was kind of frou-frou and nice, but what are the actual things you should be conversing about with your devs? First off is about their ops. What are the common repetitive tasks that they do? Are they building a database every time they provision an app? Are they provisioning a new user or new service accounts of some kind? Are they creating a load balancer, et cetera? Just observe what they do to make sure they get their app out to production. Like, what kind of pipelines do they have? What are the requirements they have to go through? Now, then we talk about, learn about their apps. So do they care about high latency or low latency or high throughput? Do they need high availability? Because honestly, I've been at places where as long as you have like 95%, nobody really cares because nobody's using it from 9 p.m. to 6 a.m. anyway. Where do they store their state? Are they storing it in like a cloud database, or are they doing it locally? Then what kind of technologies do they use? Are they already using Docker? Do they use Java? Do they use Go? Do they use Python? Identify, like I said in that previous slide, you want to identify those common patterns. So identify the common things that they're using with their apps. Just look for repeating things you hear from every customer. They might say it a little differently, but you'll see the pattern, and you'll see it emerge as you talk to more of them. The other thing is to find out about their business requirements as well. So you have to figure out what their bosses or their management expects of them. ask the question for them, like, what are the pain points of compliance? We all have to deal with that wonderful word. If we work at any major enterprise, we have to have some compliance mechanism with security this or auditing this or whatever it might be. And a lot of those, I mean, does anyone here like to do those things? If you do, it's okay. I'm not going to make fun of you. But I don't like having to deal with it. And I know that many of the people, the developers I talk to, don't want to have to deal with it either. So with Kubernetes, you can actually automate away those compliance type tasks more easily. And honestly, it makes both people happy. The app devs don't have to worry about it. They don't have to worry about complying with certain things. And then the security people are happy because all these things are automatic. Whether that's like specific egress and ingress rules or whatever, you can just automate that all through Kubernetes. So you have to find out what those requirements are as well. And oftentimes we forget to ask about that because we're more concerned about the technical details. Now, the last and probably most important is figure out how they think about their systems. This is kind of a combination of the previous points all together in one. But ask the question, how do all the different pieces fit together? What legacy things could you make easier on them? Is there some sort of legacy database they're using that maybe you could write some sort of shim that runs on top of Kubernetes and makes it easier for them? Figure out like what are their monitoring and tracing needs. Do they do any tracing or monitoring? And if they don't, could you just automatically provide some of that benefit for them without them having to do anything? And then a good exercise to do is to sit down with them and let them architect out a diagram of their system and how they picture it in their minds. Where are all their connection points? What databases do they connect to? What external services do they connect to? How are things getting routed to their application? Find out about all of those different things. Now, if you do want more specific examples of what I faced while figuring this out at other companies, you can come talk to me after. I can go more in depth about some of the stuff that I asked at the different companies and how we identified the needs there. So now that we've talked a little bit more abstractly, I want to go down and talk about some examples, some software examples here. A couple things to note before I talk about them is remember that Kubernetes is fundamentally resource-oriented. So any interaction with the Kubernetes API involves one or more API resources. Because there's all these resources, the way to protect developers from Kubernetes is to template or generate API resources for them. If you boil down all the options I'm about to tell you down to their most simple, that's what it is. You're just templating or generating an API resource for Kubernetes to use. Now, obviously, there's more on top of it, but at its simplest, that's what it is. And so, generally, the way I take it, and I think most platform devs want to take this, is like, let's do this with software. Let's not just do this manually or cobble together just a few bash scripts. Let's do it with some software. So I'm going to walk through these practical examples. There's 4 of them. Now, each of these examples could literally be its own talk. So I'm not going to go forever on each one. But we'll have some time for questions at the end if you have any specific questions about it. So first off, scripting. Now, let's really face it. You'll likely use scripting no matter which of these options you use because that's just kind of how things work. With that said, how many of you have used scripting to like set up Kubernetes services before? Anyone? Okay, a few. Okay, was the experience bad, medium, good? Okay, I'm seeing a lot of, yeah. That's kind of what my experience was. Scripting is a good option if you need absolute total flexibility. I like to joke around that the basic like Linux tools, the GNU tools, you could probably like somehow code a way to stop a moving train using a Linux terminal, but it also comes with some downsides that you need to have really good scripting practices in place at your company. If you don't already have good scripting practices in place, it's quickly going to become a rat's nest, and I speak from experience on that. But if you do have that in place and you need a lot of flexibility and ways to glue tons of different parts together, then scripting may be an option for you. Just remember that if you do go down that route, you're going to be basically scripting a subpar version of Helm, which I'll talk about in the next one. Now, just an example of this, at one of the companies I worked at, we used a little bit of Ansible and Bash to spin things up. And this is back, I think, Kubernetes 1.2 or 3. And it eventually came down to, like, it was nice to start off with. Like, it got me familiar and my coworkers familiar with what all the Kubernetes resources were, what their interactions were, learning how, like, the rolling update worked for a deployment. But you started getting into this question of, okay, which playbook do I run? Do I have all the variables set, and where am I pulling that information from? Am I pulling the secrets from somewhere specific, or where do I have to get them to? What order do I have to run these things in? So which playbook runs before which other playbook, or which script runs before another script? And then everything was in Jenkins, which insert scream emoji right there, because we had kind of had a chicken and egg. Jenkins was supposed to push our updates, but we needed to somehow spin up Jenkins first. And this is before Jenkins was a lot nicer to run on Kubernetes. It was like manually editing XML config files and loading plugins. It was kind of a nightmare. So that's where I learned that scripting probably is not the best option. But if you think it's something good for you, go for it. Next one, how many of you have heard of Helm? Okay, good. That's what I thought. If you've done Kubernetes, you've probably done Helm. Now, disclaimer, I am one of the core maintainers of Helm, so I'm slightly biased towards it. I mean, Helm, yeah. And so Helm is the Kubernetes package manager, if you haven't heard of it. Its main points are that it allows you to share and reuse applications that run inside of Kubernetes. So it's really an amazing experience when you use it the first time, because you can just go like Helm install some complicated distributed system like Cassandra, and then all of a sudden, poof, you have a Cassandra database that you can try out. It does provide some basic lifecycle management in a way called hooks. You also have this idea of a values file. The values file is the way you're able to change and manage that application or that package you're installing. That's kind of the abstraction layer right there for Helm. You'll see as we keep going through these examples that they keep getting more and more, put the layer of abstraction higher. But the values file can be a bit constraining, because eventually you're either going to template every single knob of the application into a knob inside of Helm on the chart. So you have to be careful with it. And honestly, without discipline, charts can quickly become unwieldy. In the public charts repo, that used to be kind of a mess. It's amazing now. They have a whole way of running their CI/CD that makes it a lot easier to run through the changes. But it really becomes a mess really fast, just like with scripting, if you're not careful with your charts. Helm is going to be a good option for you if there's many common pieces of software that all teams use. So if everyone's using like a MySQL database, and you're not using like a remote one that a cloud provides, then a Helm chart's a great idea, because then all you have to do is Helm install MySQL with the values configurations that you need. It's really easy to use, and you can spread that through the company. There's also other things that aren't like commonly available charts that you could write, like for security tools, logging, specific database configuration, or maybe a custom database configuration. All these things are generally like specific to a company. Everyone does logging, but it's slightly different per company. And so you can just create a logging chart that installs all the logging stuff for a user automatically. That's extremely powerful. But just remember, there's still a lot of knobs here, and users are just interacting directly with Kubernetes. If your developers like working with Kubernetes, which some do, that's totally a possible scenario, then this is a great option for them. I'd also recommend looking at some of the other tools that some of the Helm developers have created, like Draft, that make that developer experience a little bit easier and reduce the amount of boilerplate you have to do. Now, an example of this, I've used this at basically all the companies I've worked at. One powerful thing that Helm does is it gets people really excited. So if you have people who are new to Kubernetes, when they see that Helm install Cassandra, like mind blown. And so that gets people into Kubernetes and really wanting to learn how that works. Like, how did that magic all happen? Then really it made that reuse easy, like I was talking about. We were able to coordinate with a couple other people who were starting Kubernetes work at all the companies I've worked at, and kind of create a common internal Helm chart repository to share all these packages. But what we started running into is the lifecycle management became too simplistic for the use cases we had. Now, that's okay. Helm isn't meant to be like a lifecycle configuration management tool. That's not its goal. But it just became too simplistic for what we were trying to do. And then eventually, you'll start forking charts or exposing every variable, like I mentioned before, and that's what would happen to us. And so it can cause problems. If this is going to be your main way of running applications, you're going to have users who start forking it for every business group's slightly different way of running things. And so it becomes a little bit more difficult to handle. So the next option up, this abstraction, is a CRD plus a controller, custom resource definition. How many have done stuff with a CRD before? Okay, so I'm going to explain a little bit more about that because it looks like only a few. So a custom resource definition in Kubernetes is a really cool abstraction point. This is, once again, one of those knobs, but it's really powerful when you use it properly. What it allows you to do is to create any API definition you want, just a generic API definition. You submit it to Kubernetes, and then Kubernetes says, hey, now I know about this resource called foo, and you can access the foo resources just like you would a pod resource, a deployment resource, or whatever, at the Kubernetes API. It takes care of the authorization for you. You can automatically use RBAC. It basically bundles all the goodness of Kubernetes with a custom definition of whatever you've defined. And generally, when you have a custom resource definition, you've tied it together with a controller. And these controllers, or operators as they're often called, go through and they watch for those resources to be created, and then they act on those resources. A great example of this is the etcd operator that CoreOS put out. I'd highly recommend going and looking at that if you haven't. But you have a definition for an etcd cluster, which if you've ever tried to spin one of those up is an adventure. But it's about this long on your screen with normal size font text. And it allows you to specify lots of different tweaks and values for it, but then it manages the whole bringing up of the cluster, rolling cluster upgrades, whether things back up. I think there's also restore mode. And it just handles that all for you, and you have one API resource you have to do. Instead of, if you were doing that manually, you'd have to have a deployment resource, a service, probably a load balancer of some kind, or an ingress. You'd have to have a stateful set and storage backing. It's going to take care of all that for you. So the nice thing about the CRD is that now, instead of having to deal with all these Kubernetes resources, you're dealing with this many. It reduces it to maybe 1 or 2 resources that they have to worry about. Now, it's also not too hard nowadays to write one of these operators. There's something called the operator framework that CoreOS also put out. And having written controllers before that was a thing, it's super nice. You'll still have to write a good chunk of code to get this going, and ultimately, you still have people talking to the Kubernetes API. It's coupled to the Kubernetes paradigms. And so we've seen this work before. Both Jordan and I actually worked on one of these together at one of the companies where we had a multi-tenant Kubernetes cluster, and we were able to create basically a custom namespace resource because we had to have certain compliance, like I mentioned before, things in place. So certain network security policies, people couldn't go back and forth, limit on how many things they could have. And so each of these CRDs that they would create would say, hey, we need this namespace and we need you to give access to these AD groups. And it would go in and it would, when they created that resource, we would approve it. And then it would go through and automatically create the namespace with all the things in place and grant access to everyone with the AD groups they specified. And then, so this made it really nice for developers who are comfortable with Kubernetes to just get started, and they don't have to worry about all the compliance stuff. It was just there for them. They could start provisioning things into it. And it also added the ability to have a sandbox namespace so people could just play around with Kubernetes if they didn't have a lot of experience, and it would just create it for them and be done. And then reap that namespace after 12 hours. And so it was a really powerful method for us to be able to kind of create this multi-tenant Kubernetes cluster with very little effort from the users. They just had to submit one resource that we could abstract behind just a single API call or some sort of GUI that they could use to set it up and request it. Now last, this is the highest level of abstraction here, is a custom API. Now so this is custom API entirely on top of Kubernetes, and I'm kind of curious, has anyone done something like this before? Built a whole nother API on top of Kubernetes? Okay, one person. That's cool, because you're the first person. I've talked to a lot of people, and I haven't heard people do that before, but I knew I couldn't be the only one. This is kind of the farthest out of abstraction you want to go. So The nice thing about this is it's going to, like it says here, provide a very minimal opinionated interface for managing apps. And completely remove Kubernetes from the equation as far as users are concerned. They won't have to touch Kubernetes directly. They'll just have to, that's the point of the HTTP is a good delineation point. That's why we use RESTful APIs or some sort of API that's generally HTTP at its core. And that's kind of that boundary in between the services. And that becomes the new boundary. And you could literally switch it out to be console underneath if you wanted to. And they would never know. This would not be good for people who do not have a homogeneous workload of some kind. So that means like 1 or maybe 2 languages. And the example I'll give of when we did this, you'll see what I mean. But if you have non-homogeneous workloads, this is probably not the best option. It's not going to give you enough flexibility. And then also you can add too many extra knobs. And then it quickly just becomes a leaky abstraction for Kubernetes, which makes it even worse. So you have to be careful if you're going this way. Now, what we did was, at one of these companies, was we found out that as we talked to developers and had these conversations with them, basically it came down to most people were writing like CRUD apps with Java. So just basic business logic around a small API, and we're deploying those. And we're kind of like, OK, and we kept talking to everyone, and they all said the same thing. It was just basically they had a jar. And this is for before people knew how to really do containers well at this company. And so we said, OK, well, let's create something where we can upload. You just upload a jar, and then everything will happen, and you'll get your automatically like mostly high availability auto-scaled app behind. And so it would create like the signed TLS cert for their application and expose basic logs. And it kind of conformed to the organization's API standards, so they already knew how to interact with that API. But it was a nice abstraction because then we're taking away even like the container build away from them. But you don't have to go that far. It just provides something that's much further back from from like Kubernetes itself. And so then they don't have to worry about it. Because like I said at the beginning, Kubernetes by itself, as you spin it up, is not for developers. And if there's any myth I wish I could kill, it's that one in the Kubernetes land, because it's not. You throw those options in front of a developer, you're going to have problems. But if you do one of these abstractions, it'll make it much better. So leaving plenty of time, because I'm sure people are like, no, that's not a good idea or whatever for this. So I'm leaving plenty of time for questions. And if there's no questions, then either I bored you to death or I did really good, so I never know. I see one over there, yes. Sorry, can you say that again? I couldn't hear you. OK, so the question was, for 12-factor apps, which of the approaches have I seen be most useful? I've seen a lot of success with Helm and Draft, actually. A lot of people use Draft or some other tooling that they've written to kind of get rid of the scaffolding of charts, because there's still a lot of scaffolding you have to do when you start out a chart. The custom resource definition is also one that I've seen. Lastromos, if you've heard of that before, is an operator that uses Helm. And that's taking, I'm not sure if the apps in there were totally 12-factor or not, but they're close if they aren't. And those apps also worked really well inside there, because generally you're following those same patterns, and because that then becomes something common that you can abstract away. Any other questions? Oh, yes, one over there. So that's actually a common. So the question was, if you have a Helm chart that's like 95% of what most developers need at your company, and then you need to have the last like mile of, kilometer, better switch my units, of configuration done. And so honestly, that's something that's going to be easier with Helm 3 from the Helm side of things. There's going to be some ways to like hook in like library charts. But honestly, that's where the CRD and controller might be much more useful, or something like Lestromos, because you have that 95% there inside of the logic of the controller that it handles generating, and then the last 5% is what you expose as the custom resource definition. And then that might be like 10 to 20 max, hopefully, configuration options, and then they can just tweak those. Any other questions? Yeah.
What do you think about OpenShift? Would that also be an option to hide Kubernetes from app developers?
Yeah, the question is about OpenShift. I think it's a great idea. I see no problem with it. I haven't personally done OpenShift, but I know the basic idea behind it. And OpenShift is a great, if you're already doing stuff with Red Hat, then I would see no problem with doing something like that, because it does make it a lot easier. It hides that abstraction. You're still dealing with Kubernetes in a sense. I would put its level of abstraction about the same as the controller level, but it will probably provide a lot of what you need. But you'll have to see as you start using it what are the pain points and if there's some other things you might want to abstract away for some developers. Yeah?
If people are using Helm 2 now and they are thinking about Helm 3, how would they figure out how they can either get their questions answered or find out what their path is for that migration?
So the question was, if you're using Helm 2 right now, and you're kind of have questions about Helm 3 and want to kind of get ready for that transition, come talk to me. I'm one of the core maintainers, like I said, and I can help out. I'll also be giving a talk deep diving into the features of Helm 3 at KubeCon Shanghai, and all those talks, I believe, will be recorded and online within a week. So if you are interested in the Helm 3 things, come find me, or in any of these things, actually, that I've talked about. If you want to talk a little bit more about what we did, you can come find me as well. Anything else? Yeah.
Given your experience, what do you advise for a company where we don't have a platform yet, but we have Kubernetes running, and how not to scare off the developers?
So the question was, if you already have Kubernetes running, but you don't have like a full platform yet, like what is kind of the path forward? Is that a good way to say it? Okay, and kind of repair the relationship, right, from having this, oh my gosh, what are all these options, to having something more happy. So if they have already started and kind of gotten used to Kubernetes, it might be useful to just throw something like Helm at them, because it's like way easier to use if you have the charts already there. You can have somebody create some charts and then have that chart ready for them. Otherwise, if you have an idea already for your platform, I would try to narrow down on, find the group that has the most pain right now or is the most mad at Kubernetes, and then focus on their use case. Plan that platform, and then deliver it to them, and hopefully, if you do a good job, they'll probably have a good enough impression that will kind of spread to the other teams and help them also have a better relationship with Kubernetes. Yeah?
Imagine a product has microservices and other parts, which are not microservices, and that product has to live on-prem. Does it make sense to use Kubernetes in order to install that on-prem with different customers, so that basically it will force customers to also go Kubernetes?
So tell me if I phrased this right for you. So basically the question is, if you have a combination of on-prem workloads and some newer containerized workloads, non-containerized workloads, and you want to get people moving towards Kubernetes, and if it's worth it?
This is a product that you need to sell to people on-prem. Does it make sense that the product itself will use Kubernetes?
So does it make sense to use Kubernetes for an on-prem only application? Yeah. Okay. Really, I'd probably have to talk to you more about that like hallway track to understand a little bit more, because I could give a recommendation that's totally off. It really depends on the use cases, but if you're going to need some flexibility in that platform that you're building on, I guess one big rule of thumb I could say is if it's something that would be a platform, Kubernetes might be the answer. If it's not, and it's just for this application, Kubernetes might not be the answer for you. Okay, any other questions? Okay, well, just big thanks and also an acknowledgement. If you liked that art, there's the link of the person who did it. And I loved it. It was great storybook art. So anyway, if you have any questions, feel free to reach out to me, and thank you very much.